Ready? Lesson 80, here we go. You're going to need your graphing calculator today. It's going to be pretty useful for you. I'm going to show you how to set things up and do things faster. Unless you want to roll a whole bunch of dice by hand, I think we'd rather use this and have it count things for us. So you're going to need that today. I have a sheet here that, do you guys know how to do screen captures and print stuff off? If you do, this would be really helpful to take a picture of this right now, or screen capture, or the snipping tool on your Microsoft stuff. Okay, I'll be referring to that today. I'll put it under, well, I'll just show it to you, and maybe we can put it on the other camera. We're going to be doing some probability today. We're going to do some frequency distribution. And what we're going to deal with today is the difference between what's supposed to happen and then what actually does happen, and seeing how well those two things line up. But you know what? I think, like, if you finish this, you deserve like a special medal or something. Don't you feel special? I feel special. I'm going to wear this special medal because I feel special. We're all special. Okay, I'm going to move the camera and pull up some stuff on the calculator, because we're going to be rolling some dice today and looking at the possibilities for that, and then looking at what actually happens. So I'm going to move the camera over, and you'll be looking at my TI-84 next. Okay, I'd like you to turn that calculator on, and what we're going to do here is we're going to go to our apps, and I've got a list that might look something like yours, but I'd like you to go down and find this one here, the probability simulator, and hit enter. And then today we're going to be doing some dice rolling, so you can say okay. And we're going to set this thing so that we can have 2 sets of dice. Make sure you hit enter on that. Then that means we're all ready to go. And you're going to say okay and yes. And then when we want to go ahead and roll something, we just push that button that says roll. In our first example, we need 50 rolls. So what is probably the easiest thing to do is to just make note of which number got chosen first. And in my case, it was a 3. And I'm going to chuck that out when I'm all done. Okay, because I got this 50 plus here. I'm going to push that, and it's going to roll the dice 50 times to give me this bar chart. Bar chart tells me how many times each number was rolled in the thing. And so I'm going to use my arrow keys here. I'm going to push the arrow, and it's going to tell me that 2 happened once, and then 3 happened, and 3 was my magic number. So I'm going to have to say that 3 happened 4 times, not 5. Okay? That first one was a 1, then 4, and then 7, 9, 11, 8, 3, 2, 3, 1, and 1. I'm going to use that information here, but yours will look something different than mine because this is supposed to be somewhat random. But there will be some things that will be characteristically the same about both of our pictures, and that is it should be taller in the middle than it is on the ends. Okay, so that's at least how you set it up. Make sure that it's set to 2 dice with 6 sides, and then we have this way of rolling it 50 times. You can push it once a whole bunch of times and 10 a whole bunch of times to get exactly 50. But I like this. Just toss out the first number and then use, make sure you subtract 1 from that number in your bar chart. We're dealing today with stuff that's called discrete events. Discrete events are things that you can count, and things that are only going to have a certain number of outcomes. Okay, not like there are an infinite number of possibilities here with this thing. You're going to be able to count these things. And then we're going to have things called compound events, which would be like, well, like my first roll and then my second roll. Like having 2 dice that are different colors, and you say, what's the outcome of the red dice, and then what's the outcome of the white dice? Or even 2 different things. I'm going to flip a coin, and then I'm going to roll a dice. And then you're looking at the probability or the possibilities of outcomes for 2 things together. So this, again, is a common way of doing it, where you see that there's the first dice and there's the second dice. Or even at the bottom here, it says you've got the the first event, the first roll, and you got a second event, a second roll, and they've turned it into a chart so you can see all the possible outcomes of that. What we're going to do today is we're going to use some of that information we're going to gather, and then we're going to make a chart that shows the results of that. We're also going to look at what are the chances of getting something like that. So I've listed out my numbers here in a chart. First of all, I've got the sums that are possible when I roll 2 dice. And then I put also then the frequency of times that happened when I did it randomly. Okay, so you should probably write yours down somewhere so we can kind of compare our numbers. It would be kind of fun for you to take a picture and send it to me, and then I can collect that data and kind of see overall what our distribution looks like of these different numbers. Okay, so one thing that we do know is that the total number of things, total number of rolls there was 50, okay? So not only can I figure out what the frequency was and make a frequency distribution, but I can also figure out what were the probabilities or what were the percentages that each number happened in my stuff. What I also want to know is what should it look like, okay? If I was going to roll 2 dice, I'm going to have some different possibilities for getting different numbers. And I'll start in the middle with 7. Hi, Mr. Palm. Would you like to make a special appearance?
Is it a movie?
Yeah, just say hi to everybody. Hi, lesson
Hi, everybody.
80. Here we go. So I'm going to look at how many different ways I can get a 7 rolling 2 dice. And there they are. It's 1, 2, 3, 4, 5, 6. There are 36 total things in here, so really 6 out of 36 is about the amount that I should get. That's about 17%. And then if you think about it, there would be what? Oh, this is hard to do backwards, isn't it? There we go. Oh, I can't follow it. There are 5 ways to get a. Oh, I put that in the wrong place. 5 ways to get a 6 and 5 ways to get an 8. Move this over here. 6 out of 36. 5 out of 36. And on down. 4, 3, 2. There's only one way to get a 2. That's snake eyes. 4, 3, 2, 1. And only one way to get the biggest number, 16. So that would give us some indication of the percentages that we should expect to get. But then there's actually what happens. Like, I have 3 girls. You know, what are the chances of that? 1 in 8. But that's what I'm really good at, is making girls. So that's what happened. Some families have like 6 boys. So it would be kind of fun to figure out what those percentages are. But right now we kind of want to look at just what the frequencies happen to be. And that's what this is. 5 out of 36 times you should get a 6. 6 out of 36 times you should get a 7. My data was a little different than that, so I'm going to draw a little bar chart here to show you my distribution. I got 2 once, and so it's going to make a little bar here. This axis is labeled frequency, how many times did it happen, and this side is labeled outcomes, so 2 through 12. So I'm just going to really quickly make myself my chart. But it's the same thing that was on my calculator when I did my stuff. 6 happened 11 times. Oh, we got to put a new number up there. 7 happened 8 times. 8 happened 3 times. That's kind of weird. 9 happens twice. 10 happened 3 times. And 11 and 12 happened once. Now, depending on what game you're playing, that might be good, that might not be good. We were talking the other day about, what was it, craps? You get like 12s and 11s and 2s and 1s and stuff, 7s. They use those numbers and the probabilities for those things to see what they get. So yours will look like this, but it won't look exactly like this. Well, if it does, then we need to investigate like what's wrong with our calculators, because that probably shouldn't happen very often. Okay, so this is I used a bar graph to show the distribution of my data. I collected the data first by getting 50 data points, and then showed you how often I got one thing or another. We can compare that then to our experimental probabilities. Let me get my calculator out real quickly, and I'll just do a few of those. We had 11 sixes. That was a 11, escape, yes, quit, yes. 11 out of 50 rolls were a 6, and that's 22%. I should really only be getting about 14%, so that's a little weird. And then I'll check another one here. I'll go with, how about 3? Okay, I should get 3 only 2 out of 36 times. Should get it about 5.5% of the time. I got it 4 out of 50, which is about 8%, so that was a little high. Some will be a little high, some will be a little low, but it all should kind of shake out if you did it enough. If you decide to do it like 1,000 times on here, then it should become a lot closer to what the probabilities say that you should get. So this lesson is all about kind of knowing what are the chances that something would happen, and then trying the experiment itself and kind of comparing those or displaying them in a way that makes sense. So there's lots of bar charts in here. Matt, you'll like example 1 because it talks about baseball and different kinds of hits you can get. And you know that the more bases that you get per hit, you have a higher slugging percentage. So that's kind of interesting. Example 1 kind of lays out somebody's slugging percentage in a sense, or their distribution of outs, walks, singles, doubles, triples, and home runs. And this looks like a leadoff hitter here. Not a big bat, but gets on base a lot. So you take the total number of things altogether. In this case, it was 99. And then you just say, how many out of those were walks? 30 out of 99. 36 out of 99 times he walked. 20 times out of 99 he got a single. That makes a fraction or a frequency, and you can turn that into a decimal if you wanted to, and then display that data in some sort of bar chart. Again, they're going to have frequency on the y-axis and all the possible outcomes on the x-axis. And for those, it really doesn't matter what order they're in, but of course it would make sense to have outs, singles, well, probably outs, walks, singles, doubles, triples, and home runs in that order. Okay, this was pretty simple because it's the least number you can get with rolls to the highest number you can get with the rolls. Also, if you look at example 2, example 2 looks a lot like the bottom of this chart, where we have a first thing and a second thing that happens. In the book, they have heads and tails being the first event, so they're flipping a coin. And their other event is like picking marbles or something. Spin a spinner that has different colors. But the probability simulator, if you notice, can toss coins. It can roll dice. It can choose marbles that are different colors. It can spin a spinner if you'd like to. It can draw random cards, or it can even just generate a random number up to a certain size that you want. So there's lots of ways of simulating different events, and then you just collect the information, or you think about what the possibilities are, and then you list out those frequencies when it actually does happen. So lots of bar charts that you're going to have to draw here. Example 4 uses the letters that you find in the word Mississippi and how many times they occur. But again, frequency is always the vertical axis, and the different possibilities of picking a letter randomly or flipping a coin or whatever the case may be. Those happen to be on the x-axis. Okay, so there's lots of variability here. There's a question about bowling, which I did yesterday. I bowled 117 without bumpers. That was pretty good for me. Though Durham got his best ever score of like 177, so kudos to Durham. He probably should get an award. But you get an award too, because you're finishing up lesson 80. And that means you have one thing left to do besides this lesson, and that'd be take that last test. So let me know when you're there. We'll celebrate together, and then we'll start the new year doing something completely different.